Assalamualaikum warahmatullahi taala wabarakatuh. My name is Muhammad Nabil bin Mazlan, metric number S67802. So I will present about my individual assignment for CHM 3333, which is a coordination chemistry. So for the title is a metal complexes. This is my journal title, which is Synthesis, Characterization, and Biological Application of some Transition Metal, Complexes of N-benzo-D13-deoxylphenylmethylene isonicotinohydrazide. For the first one, we will draw a structure of a metal complex. So this is a metal complexes that I have drawn based on the journal that I have choose. So for these metal complexes, we have four different metal center. So I have choose a nickel for my metal complex. For the second question is determine the oxidation number of metal ion. So for my metal center ion, which is a nickel 2, so it has a ligand that attached to the central metal ion. So we must calculate all the charge of the ligand first, and then we combine them all together to calculate a metal center oxidation number. So charge of IMP is 0, charge of aqua, which is water, is zero 2, and charge of chlorine or halogen is negative 1. So we calculate them all, and oxidation number for nickel 2 is positive 2. The third question is a ligand name explanation. For a ligand name, which is INP, so it has a several process to create this ligand to become INP. So for the first one is starting material. So isonicotinic hydrazide, which is INH, this is a known anti-tubercular drug with an isonicotinic acid group, which is a pyridine ring with a carboxyl group and a hydrazide functional group. So piperonal benzo D13-deoxylphi carbaldehyde. This is an aromatic aldehyde with a 1,3-deoxyl ring and an aldehyde functional group. The second one is a condensation reaction. The carbonyl group of piperonal reacts with one of the hydrazide nitrogen atoms of INH through a condensation reaction. This reaction results in the formation of a new carbon-nitrogen double bond, which is imine or azometine, between the two molecules. The remaining nitrogen atom of INH and the hydroxyl group of the deoxyl ring remain unperturbed. The last one is a ligand name breakdown. So it has all the ligands before proceed to the full metal complexes. So the first one is N-benzo D13-deoxyl 5-methylene. This part describes the substituent attached to the hydrazide nitrogen that form the imine bond. The second one is a N, which is a nitrogen. This indicates the specific nitrogen atom involved in the bond formation as INH has two. The third one is a benzo D13-deoxyl 5-ene. This describes the deoxyl ring with a carbon attached at the fifth position. A methylene, this refers to the CH2 group connecting to the deoxyl ring to the imine nitrogen. And the last one is isonicotinohydrazide. This part refers to the remaining portion of the molecule, including the isonicotinic ring and the other hydrazide nitrogen. Next is a complex name explanation. So a complex name for my metal complexes is full name is dichlorotetraaqua INP. So it has a little bit error there. It's not an indium phosphide, but it has a long name that I have mentioned in the previous slide. So dichlorotetraaqua INP nickel 2 complex with two additional water molecules of salvation. So here are some additional points to note. So the square brackets around the metal complexes part indicate that these ligands are bonded directly to the central metal ion. The dot separating the metal complexes and chlorine parts indicates that the chloride ions are not directly bonded to the nickel ion, but rather interact with the complex ion electrostatically. And the last one, the parentheses around H2O2 indicate that these water molecules are not directly bonded to the nickel ion, but are associated with the complex through hydrogen bonding or other weak interactions. The next one is a preparation of N-benzo D13-deoxyl 5-L-methylene isonicotinohydrazide. So it divided by two parts of preparation. The first one is a preparation of N-benzodimethylsulfide L-methylene isonicotinohydrozide. So the reaction of isonicotinic hydrozide with piperonal in ethyl hydroxide was heated under reflux for 2 hours. White precipitate was formed after cooling down to the room temperature, filtered, recrystallized from ethyl alcohol, and dried out in a vacuum desiccated over anhydrous calcium chloride. The second one is a preparation of metal solid complex. The metal chloride was added to the INP, dissolved in ethyl hydroxide, dropped wisely. The mixture was heated under reflux for 2 hours, and the developed solid complexes were filtered while hot, washed effectively with pure ethyl alcohol and diethyl ether, and finally dried in desiccated over anhydrous calcium chloride. Next is a electron number n in d-n orbital of the metal ion. So electron number for nickel 2 is a D8 because based on the periodic table, base value of a nickel is 10 electrons. So from an oxidation number that we have got, which is positive 2, we must minus them by 2 from D10 and become D8 for nickel 2. Next is the microstate table. So before we get to the actual microstate table, we must uh, make a little bit of work to find all the microstates that possible in the microstate table. So for D8, which is for nickel 2, it has 45 microstates. So this is the work that I have to do. So this is the microstate table that I've built based on the work that I have do in the previous slide. The next one is a transition in UVV spectrum. For the left diagram is a UV for nickel to spectrum based on the journal, and the second one or a right diagram is a Tanabe-Sugano diagram for D8. So this is three electronic transition possible that based on the Tanabe-Sugano diagram for D8. So the nickel to complex spectrum display bands at 15,015 and 12,275 centimeter designated to these three electronic transitions, so respectively of nickel to ion possess an octahedral structure. So it is an inflict state because the microstate representing that it has two unpaired electron. So in its orbital diagram. So for the 8 configuration of nickel 2, there are no high spin or low spin complexes possible. Thus, the Tanabe Sugano diagram for D8 is not divided into two parts just like D6, D7, or other below. The last one is an application of the complex. So we have several application that we can use based on the journal of these metal complexes, but I have choose one only. So it is in vitro anti-cancer activity. So the hepatocellular carcinoma is foremost kind of liver cancer, accounting for the second highest rate of cancer-related mortality, whereas ovarian cancer is one of the most frequent gynecological malignancies. Only approximately 30% of patients survive because its chemotherapy resistance that is main hindrance influencing the treatment success. That's all from me from my individual assignment. Thank you.